Hello, everyone, and welcome to another episode of SRE 101, a podcast about all things infrastructure and reliability. My guest today is Suman Chakraborty. He's a senior cloud architect at VMware who specializes in Kubernetes deployments. Suman, it is so exciting to have you today. Welcome to the show.
Yeah, thanks, Raghav, for having me in your show. And I'm also pretty excited to have a nice conversation with you on our topic.
Let's start with some introductions, Suman. Tell us a bit about yourself. What have you been up to?
Yeah, yeah. So I'm working as a senior cloud native architect with VMware, and I'm having overall 13 years of experience in the field of cloud, DevOps, and IT system administration. So I'm more from the platform engineering background, and in my current role, I'm helping customers navigate the complex path of making the leap towards app modernizations from a non-cloud to a cloud-based environment. And we do this with the help of a suite of tangible VMware products that we help customers to understand how to use the product, provide the best practices and guidelines of using them, and basically help them to set up their environment in the production for their application workload deployment. So I have been working on DevOps and cloud native for almost like 6 years now, and I have started my career working into private cloud, especially with OpenStack. And later, then I moved more into the platform as a service with Cloud Foundry, Docker, and now with container as a service with Kubernetes. Actually, during this whole journey, I have done many acts as a consultant, as a lead DevOps engineer, senior cloud native architect in basically building solutions that were robust and supported on production environment. I do a lot of microblogging on social website, basically trying to help the community to have knowledge more around the cloud and the DevOps areas. So
Yeah.
that is, and also I'm a tech speaker. I have spoken many conferences, mostly with Open Source Summit, HashiCorp, Docker event, and also with the DevOps India Summit.
As part of all your experience, I get that you've seen many good days and also many dark days.
Yeah,
And yeah,
yeah.
that's perfect. Suman, I guess it is very easy for anyone to understand what a pattern is, right? I see patterns in life every day, but what exactly is an anti-pattern? Before we even dive into Kubernetes, like what is an anti-pattern? Why is it such an important thing in engineering?
An anti-pattern is a kind of a pattern which doesn't yield good results. Okay, so if I say it is some sort of practice or solutions that will not help for a long term in implementing or in basically deploying our software, or if I say that those principles and practices doesn't align with the cloud native principles when we speak more from the DevOps background. So anti-pattern is something which provides a solution that solution is kind of bad, if I say, and it leads to an overhead for the DevOps engineers, DevOps or the SRE engineers to maintain additional tasks which would have not been needed if we would have maintained a proper guide on how to implement that solution.
So coming specifically to Kubernetes, we all know that anyone who's using this tool is probably relying very heavily on it, right? I mean,
Mhm.
Kubernetes is meant to be the backbone of your infrastructure. Maybe the entire system runs on it, so you can't really afford to make big mistakes, especially foundational mistakes, in such a significant
Right,
component of your infrastructure, right? So
right,
what are
right.
some known anti-patterns inside Kubernetes itself?
Mm.
What happens if I choose to ignore these anti-patterns, or I'm simply unaware of it when I'm setting up a whole Kubernetes deployment for a company, right? So does it come back to bite me?
When we think more from the Kubernetes ecosystem point of view, there are a lot of anti-patterns actually that can be found. Now, some of the anti-patterns might not basically cost too much to the organizations if they are planning to just run Kubernetes on their dev or in a non-prod environment. But if they are planning to run Kubernetes on a production environment, that can actually have very catastrophic results. A very common usage of the best practice has been seen where there is a tendency where we try to bake all the configurations that is available for our environment into a container image. So some of the teams basically tend to tend to, while trying to segregate different environments, they try to create different container image and bake the environment configurations inside the image. Like for example, let's say they may bake the IP of the URL of the application that would be running on that particular environment. Even they would hard code the secret, the password, which is there inside the container
Oh,
image.
so
Right?
there's like a different Docker image for prod. There's a different one for
Yeah,
dev staging.
dev
Okay.
staging unity. Right, right.
Yeah.
Now, the problem is like this is good as long as they are using on a dev environment because one way we just try to minimize the dependency of the dev from the ops because we are just providing everything on that image. So once they run that image on a container platform, whether it's a Docker or Kubernetes, then they are able to get the exact result that they want, right? Like they may hit their application URL, they would be able to log in because we just baked all the secrets and passwords inside that image, everything, right? However, in a production-based environment, this is not good. Or if I say if you're managing multiple environments, which are kind of production line, is not a good practice. Since if you are managing every configuration within your container image, then it becomes an overhead of changing every configurations in the image whenever there is any update that is happening on the configuration side. Let's say, for example, one of the common example can be like you might have you might be using one of the secret identity tool as in your dev environment. Let's say Hacktico. Now you realize, so I need to change it to secret manager, AWS secret manager, and you have already embedded all the configurations in that image. Now, what happens at the later point that you need to change every image definitions with the newer secret tool that you are using, right? So that is not the correct way that you should do. Ideally, the best practice, which is laid, even it is part of the 12 factor principle, which basically is the guideline of deploying a microservice in a very cloud native way, states that you should always uh, keep your configurations outside your container image. So what happens like you create a golden template or a image, whatever you say, and then you use that across all your environment. The image properties would remain the same, except what you are supplying from the environment is the configurations related to the specific environment. Let's say, for example, in a dev environment, you might be using a label. Let's say you just give a dev label, and also in the Q environment, you might be using another label to identify Q. So you basically pass all on these properties, all these configurations separately when that particular image is being built on the platform. So you retrieve that image from your central repository and build the configuration separately from individual environment. And that way you try to maintain some sort of segregation between
Yeah.
the actual application image that you are trying to deploy and your configurations which are coming from the environment side. And so this is very a common anti-pattern which has been observed. The other one might be whenever you are deploying a country's image. We often, because we might be in a hurry, right? So SREs are always in a hurry to do to fix things. We never know when a platform can get down. I mean,
Oh yeah. Yeah.
it can go down, and basically, if the travel is coming up, and so because you have very short time to do all those rapid fixes, you unintentionally basically pull an image without mentioning any tag. Right now, without mentioning tag means you are just pulling the latest image. Now, what happens if that latest image uh, is not the one which is basically being scanned thoroughly by any security or compliance scanner, right? So you might end up introducing a known security vulnerability in your environment. So this is a very common practice that happens. I mean, I myself have done it in dev environment. I know that in
Yeah,
dev,
I'm
anyway,
I'm
it's
guilty
fine.
of that too.
Yeah, like when we run just Docker run Nginx. Now, even Nginx go with the latest, nothing matters because I know Nginx images fine. There's no security, but who knows? There can be a known vulnerability. Like when you
Yeah,
have seen that log4j issue when it came up, right? No one knows that an image that containerized images that were deployed from the artifactory or the known registry would have contained those log4j
true.
critical vulnerabilities, right? So that's why a very best practice would be to always mention a tag specifically when you're pulling the image. Even whenever there are any changes that is happening, you can actually refer back to that tag and undo those changes. Because when you are doing it with the latest tag, the latest seems to keep updating whenever there's a new image that gets pushing in the
Hmm.
registry. So these are very common anti-patterns which are should be avoided. I mean, there are more, but these are very common that we see happening in
True,
while
true, true.
managing multi-cluster environment.
Yeah, and I totally agree with these approaches because even when you're using the concept of a golden image, which is one standardized image that you use, and then you supply your configurations via, let's say, the config maps in Kubernetes or secrets
Yeah,
or Vault or any of these things, right? That also that means you're injecting it into the environment of the container. It also gives you an opportunity to refresh these configurations pretty quickly. Like once you make a change in the configuration, how quickly does that actually propagate to all your applications?
yeah,
That's a
yeah.
lot quicker if you don't bake all those configurations in your image.
Make all the
Otherwise,
things. Yeah, because
you're going through the
yeah,
whole build stage again.
yeah.
Yeah,
Some configurations may not even need to restart any pod, so that is well good, right? You just change it wherever it
exactly.
automatically gets reflected in your running workload actually. So,
Anti patterns often form because we decide to apply short term solutions to issues, right?
yeah,
I mean, these can be out of laziness, or if like you mentioned, if there is a problem that needs urgent fixing,
immediate
and
fix. Yeah,
yeah, and can't wait for a long term solution to be in place, right?
yeah,
That's when anybody is like really pressed into just using an anti pattern, and there's always a technical debt that has formed, and we are like, okay, we'll fix it later. How do we navigate this dilemma in everyday operations? Like, how do we choose whether to
yeah.
adopt a short term solution or a long term solution?
We are always in a hurry. No matter where we work, we always try to find a quick and easy solution that can actually fix our problem, because at the end of the day we don't want to go with a problem after closing or shutting down our system, right?
Right,
So
right.
having said that, anti-patterns impose a lot of overhead on the engineers managing a system in the long run, right? So as I say, there are no shortcuts to it, because these solutions need to be thoroughly analyzed, thoroughly discussed between the teams before they can actually be implemented.
Yeah.
What are the solutions that come from the anti patterns that we see, right? So we should not follow a very shortcut solution to deliver anything, because at the end of the day we may be happy that okay, we have done something that fixes a problem, but maybe after 2 months or 3 months it can recuperate back. I mean, it can come back as a boomerang and say, okay, again we are stuck again on the same issue, right? One of the common example I can say is basically, if you have seen, we often do, and I mean it's a very general thing that we forgot, is imposing limits on the pods in terms of the containers usage, like how much memory and CPU our containers can use
Oh
within
yeah, yeah.
pods. We
That's
never
that's
impose
super
the limit.
crucial.
I mean, this is very common thing that we always miss. I mean, okay, it's good till the time you know that your app is not scaling up, or let's say you are not trying to deploy more workloads, or let's say if you have a larger infrastructure. But what happens if neither of these options is applicable to you? Then it basically leads to resource starvation. Initial few months, you might see spikes coming up in a report that at certain point of time, some of the containers within the pod have used more resources whenever there is more traffic burst that is happening. While at certain point of time, after certain point of time, you will see kill error, like out of memory error that is often coming in your pods. You might not be knowing why it is coming. It might be because one you have done an update on that particular for that particular workload, and that newer image might be using more memory usage
Yeah,
on your pod. So we always say that since in namespaces by default there is no default quota that is implemented, we should always place limits. Actually, we should not actually focus more on the limits, but we should focus more on the requests that we are giving. Like if we are trying to deploy a specific application, how much memory and CPU it needs. This is something again as a DevOps engineer you might not be knowing, so you might need to consult with your developer and also maybe with an architect, and knowing that this application can scale up or it needs to handle more amount of traffic in certain peak hours. So you should always keep some minimum threshold and maximum threshold for that particular application to go up. So by that design, you basically create your deployment so that it can actually use that much required quota that is assigned to it. So you impose a request and a limit that is always there, and so you basically prevent any kind of overcommitment of your resources that is there within your pods that you're running. So if you're running a multi-container based pod, it always happens, or we have seen happening in a sidecar based approach, or wherever you are running one helper container that is basically doing a job of, for example, taking all the logs, pulling it, and sending it to any external logging mechanism, a Splunk or something, and your main container that is actually running your core application, right? So this things often comes here. So I mean, this is one of the very known example I'm giving you when we try to find out any short term fixes. So we should not create any deployable workload without imposing any limits on the pods that we are trying to run on the specific application. So yeah, so there is no short term fix, but we should uh, reinvent the solutions that are best for the environment where we are managing a workload, because not every environment would be same across the organization. So based
right,
on that, we
right.
always come up with the best practice that we can actually implement.
To be honest, I learned the lesson about the limits the hard way myself, because I have dealt with the noisy neighbors problem in the
Not in
past,
everything.
where where some sample application which was deployed in a prod environment actually ate into the memory of a MySQL writer node, and that's the
Yeah,
sort of thing you don't want to end up having. So definitely imposing limits. Yeah, that's a very
yeah,
good example. Let's say we have set up a foundational some foundational aspects of our Kubernetes deployment, right? The basics which allow us to achieve what Kubernetes was meant to give you, which is deploying our applications. That kind of foundational stuff is done, good. But when it comes to the day two operations of Kubernetes, right? By day two, what I mean is things that are still needed to make our Kubernetes deployment production ready. Okay, so these
yeah.
are things like observability, upgrades, a process around upgrades, security, backups,
Backup
and
and
disaster
recovery.
recovery.
Yeah.
All of these things, right? These are day two operations which are still needed to make my Kubernetes cluster production ready. Are there any common anti patterns you observed here as well?
Yeah, as you mentioned, like more than day one, day two is super critical, because here is what we are actually providing the boundary in terms of um, creating a robust foundation for the production ready platform that we are building for our Kubernetes on our Kubernetes environment. Also, there are a lot of best practices which we often forget because of the mode where we want to implement everything within a day, which is always not possible, because there are some things that you need to basically go in a gradual fashion. You need to observe how your platform is behaving before you can actually impose that specific solutions on your environment.
Right.
So, but managing both the infrastructure as a code based delivery and the application deployment on the same pipeline. and that is not the best practice going forward. So we always think, okay, we use like Jenkins pipeline to deliver a Terraform based code to bring up our infrastructure. Okay, why not use the same pipeline to deploy application, and we'll just change our basically the declarative pipeline code and put some Ansible code, and then that would basically go and deploy the application. Don't do that, because that is not only a very tedious thing to do, it is super difficult to maintain in a long run. One of the common challenges that comes while managing this kind of pipelines, we might thinking, okay, we are managing smaller pipelines, so manageability becomes easy. No, that's the other way around. If something goes wrong while deploying your infrastructure, your developer might be sitting idle for a long time thinking, okay, my application is still need to run. I need to test whether the Ansible script will actually work to deploy that application, create that, or physically deploy on our platform or not. And that the infrastructure platform, the infrastructure pipeline may take around 1 hour to do the its entire task. So why should we do that? Let's segregate the concerns here. We basically build a separate pipeline for infrastructure and a separate pipeline for the application. And when we talk about managing both the pipelines, so uh, from the concerns point of view, then the developer don't have any dependency on the infrastructure team to test his applications, right? Because they are actually managing their show all along on a different pipeline altogether. So that is something which we have seen very often in while teams are managing their day-to operations, not segregating the duties of managing infrastructure and applications in two different the automated pipelines. I mean, pipelines is not only just Jenkins; it can be anything. It can be simple GitLab pipelines that you are trying to do, like running some GitLab or
But
GitHub
as long
Action.
as we are segregating those, that's what
As long as
matters.
you're
Yeah.
segregating, that should work good. Yeah. So this is one common anti-pattern that we have observed. The other anti-pattern that we always see is basically many teams, while doing kind of a rolling update on their application, they don't use the best principles that are governed from the microservices strategy, like using blue-green deployment or canary testing or A2B deployment. They simply rely on the Kubernetes native deployment strategy, which is recreate and rolling update to do that. Don't do that, because if you are doing it, as long as your workload is small, it is fine. But what happens when you are managing multiple different development workloads, right? So it might not work in the same fashion. And
Yeah.
also, one common thing is that we need to test out the application traffic, right? How much traffic is actually reaching to the application pod, and what is the percentage which is missing. You cannot actually rely on simple native deployment strategies like rolling update or recreate to measure this usage. Actually, you can only do that using the deployment strategies, either using a blue green strategy or a canary testing, where you can actually use or you can basically provide the users a certain percentage of the application so that they can test before they can say that, okay, this is production ready, and you can basically shift the traffic in an incremental way on the
Yeah.
production route. So, so that is also a very common anti-pattern that we have seen. So yeah, I mean, these things we need to keep in our mind when we are managing a day-to operation, and also not only day two but like day three, day four, and day nine, because these things will keep on coming as and when we will keep on deploying more applications. Our cluster would be growing, and these things would become more vivid. We'd be requiring more number of configurations to maintain those kind of huge cluster configurations. So yeah, those are
Yeah.
would be very important, super important. Yeah.
What is the deadliest anti-pattern that you've ever seen out there? Like, you know,
Yeah.
when it's like when you saw it, you're like, you guys are sitting on a landmine right now. Don't do this. Have you ever come across something like that?
I was not sitting in a landmine kind of thing like situation, always. But yeah, with some of the very worst kind of anti-pattern that I've seen would be where we were not actually, or one of the, I would say that, uh, um, I won't say that it was kind of a very deadliest thing, but I would say that we did a lot of stuff to manage or to suffice a very small thing which would not be needed.
Yeah.
So that common example would be like when we talk about doing any. So when we talk about bringing interconnectivity between our clusters, right? We always rely on the services how they are going to talk with one another. But now in this common, I mean, Kubernetes trend, there is always a very, I mean, catchy thing which is called a service mesh that we always go and tend to implement. But we must also realize that not every deployable infrastructure needs a service mesh. Especially in the case where we don't need to basically do kind of any rate limiting, or we don't need to do any authentication authorizations on the HTTP API calls that is landing onto the control plane. Like it's simply, let's say for example, if there is a front end service and we need to just connect to the back end service, why implement such a complex process of building a service mesh to do that job, right? It can simply that you can stick it on a load balancer and on the front end application pod, and that front end would automatically be connected via cluster IP kind of service and send it back to your send it back to your backend database. I mean,
Right.
I'm just talking about a very smaller solution, but because we always go with the trend, we always go and try to implement any known service mesh solution because we think that not only is just about connectivity, it's just about securing, it's just about providing rate limiting, it's basically providing the mutual TLS, all those things. These are always good, I agree. But when we are scaling up our scaling up the architecture, right? When we are thinking about, let's say, doing a entire based in tire architecture deployment, then we can probably think of doing that. But I have seen people doing service-based implementation in dev environment that is actually not needed because that
That's
actually brings
totally an
a lot of
overkill. Hmm.
more complexity. Like you end up creating one more helper pod that is basically running beside your application pod, which is basically creating that connectivity across two pods on the control plane to send out the communication traffic, and that is some way eating away all your infrastructure resources. Like at the end of the day, you complain that, oh, okay, I don't have enough capacity to deploy any more workloads because my resources are being used up by the my control plane nodes. So that is not the way forward. Like if you are just trying to manage simple deployments, just go with the services. You don't have to always like. I mean, services are well good till the time it's just about connecting two tier applications where you have a front end, you have a back end, or even three tier, you have a Redis or let's say caching service that is connecting at the back end. But I mean, you don't need to implement a very complex solutions as a service mesh to implement those kind of communication parts. So yeah, that is one of the deadliest anti-pattern I have seen in my previous companies in some fields where they were trying to implement that. So yeah, so that was my experience actually.
Yep, yep, makes sense, and I totally agree that in a dev environment, it's probably an overkill. You're
It's an
introducing more
overkill.
operational burden. You're
Yes,
probably spending more resources and money, and
yes,
there's actually no ROI on that. So,
no, yeah, yeah.
Suman, thank you so much for coming on our show today. It was very insightful chatting with you about Kubernetes anti-patterns. Cheers.
Thanks for having me.